Alright, I'm in the Pilot's Handbook of Aeronautical Knowledge. I'm in Chapter 15. This will be 15-5, Measurements of Direction. Measurement of direction. By using the meridians, direction from one point to another can be measured in degrees, in a clockwise direction from true north. To indicate a course to be followed in flight, draw a line on the chart from the point of departure to the destination and measure the angle which this line forms with a meridian. Direction is expressed in degrees, as shown by the compass rose in figure 15.6. Because meridians converge toward the poles, course measurements should be taken at a meridian near the midpoint of the course rather than at the point of departure. The course measured on the chart is known as the true course, TC. This is the direction measured by reference to a meridian or true north. It is the direction of intended flight as measured in degrees clockwise from true north. As shown in 15-7, the direction from A to B would be true course of 65 degrees, whereas the return trip called the reciprocal would be a course of 245 degrees. Yep, courses are determined by reference to meridians and aeronautical charts. So, the true heading, TH, is the direction in which the nose of the aircraft points during a flight when measured in degrees clockwise from true north. Usually it is necessary to head the aircraft in a direction slightly different from the true course to offset the effect of wind. Consequently, numerical value of the true heading may not correspond with that of the true course. This is discussed more fully in the subsequent sections in this chapter. For the purpose of this discussion, assume a no-wind condition exists under which the heading and course would coincide. Thus, for a true course of 65 degrees, true heading would be 65 degrees. To use the compass accurately, however, corrections must be made for magnetic variations and compass deviation. Variations. Variations in the angle between true north and magnetic north. It is expressed at east variation or west variation, depending upon whether magnetic north is to the east or west of true north. The north magnetic pole is located close to 75 degrees latitude, 96 degrees longitude, and is about 1,300 miles from the geographic or true north pole, as indicated in figure 15.8. If the Earth were uniformly magnetized, the compass needle would point toward the magnetic pole, in which case the variations between true north as shown by the geographical meridians and magnetic north as shown by the magnetic meridians could be measured at any intersection of the meridians. Alright, so magnetic meridians are in red, and while the lines of longitude and latitude are in blue. From these lines of variation, magnetic meridians, one can determine the effects of local magnetic variations on magnetic compass. Actually, the Earth is not uniformly magnetized. In the United States, the needle usually points in the general direction of the magnetic pole, but it may vary in certain geographical localities by many degrees. Consequently, the exact amount of variation at thousands of selected locations in the United States has been carefully determined. The amount and direction of variation, which change slightly from time to time, are shown on most aeronautical charts as broken magenta lines, called isogonic lines, which connect points of equal magnetic variation. The line connecting points at which there is no variation between true north and magnetic north is the agonic line. An isogonic chart is shown in figure 15-9. Minor bends and turns in the isogonic and agonic lines are caused by unusual geographical conditions affecting magnetic forces in these areas. So, okay. On the west coast of the United States, the compass needle points to the east of true north. On the east coast, the compass needle points to the west of true north. 0-degree variations exist on the agonic line, where magnetic north and true north coincide. This line usually runs roughly west of the Great Lakes, 0-degree variation. West of the Great Lakes, south through Wisconsin, Illinois, western Tennessee, and along the border of Mississippi and Alabama. All right. Because courses are measured in reference to geographical meridians, which point towards true north, and these courses are maintained by reference to the compass, which points along magnetic meridians in the general direction of magnetic north, the true direction must be converted into magnetic direction for the purpose of flight. This conversion is made by adding and subtracting the variation, which is indicated by the nearest isogonic line on the chart. For example, a line drawn between 2 points on a chart is called a true course, as it is measured from true north. However, flying this course off the magnetic compass would not provide an accurate course between the 2 points due to 3 elements that must be considered. The first is magnetic variation, and the second is compass deviation, and the third is wind correction. All 3 must be considered for accurate navigation. Alright, what are we at? Magnetic variation. As mentioned in the paragraph discussing variation, the appropriate variation for the geographical location of flight must be considered and added or subtracted as appropriate. If flying across an area where the variation changes, then the values must be applied along the route of flight appropriately. Once applied, this new course is called the magnetic course. Because each aircraft has its own internal effect upon the onboard compass systems from its own localized magnetic influencers, the pilot must add or subtract these influencers based upon the direction he or she is flying. The application of deviation taken from a compass deviation card compensates the magnetic course unique to that aircraft's compass system as affected by localized magnetic influencers, and it now becomes the compass course. Therefore, the compass course, when followed in a no-wind condition, takes the aircraft from point A to point B, even though the aircraft heading may not match the original course line drawn on the chart. If the variation is shown as 9 degrees east, this means that magnetic north is 9 degrees east of true north. If a true course of 360 degrees is to be flown, 9 degrees must be subtracted from 360, which results in a magnetic heading of 351. To fly east, a magnetic course of 81 degrees, 90 degrees minus 9, would be flown. To fly south, a magnetic course of 171, 180 degrees minus 9. To fly west, it would be 261 degrees, which would be 270 minus the 9. To fly true heading of 60 degrees, a magnetic course of 51 degrees, 60 minus 9, would be flown. Remember, if variation is west, add. If east, subtract. One method for remembering whether to add or subtract variation is the phrase, east is least and west is best. Alright, let's look at only other charts were here on 15.7. Alright, so we'll hold off there. There was a 15, 15.6 and 15.7 going into 15.8. That was a variation. Magnetic variation, magnetic deviation, deviation. Going into deviation now. So that's it. 15-7 and 8. See ya.